Hey guys, and welcome to Topic H, Angles of Elevation and Depression. So before we look at word problems, we're going to have to look at a few vocabulary words, and then what we're going to do is just set these things up. So what is an angle of elevation and depression? Well, it depends on where you're looking at in a triangle. Our pictures will always look the same no matter what, and the angle that we end up talking about will always be in the same spot. So if I look right here, it's my elevation angle. And that's because if you think about it like an elevator, it's going up from the ground. Now, right here, it's a depression because it's going down. You're looking down, and this is where you look. So if I'm over here, here's my little person, and I look, this is where I'd be looking if I was looking straight, and I look up, and over here, here's my little person, looking straight, I look down. Now, what's so special about this? This line and this line are parallel. So that means that these, if you remember right, are my alternate interior angles, or my Z angles. So no matter what, whenever I look at a triangle, I'm always going to put my angle of depression and angle of elevation in the same spot inside that triangle. And that's the what's so important about the angle of elevation or depression. They go in the same spot. So I'm going to draw the same picture no matter what. I always have my little triangle, and that's it. Now right here where I put the star, that's going to be my angle of elevation or depression. So let's look. Suppose an angle of elevation from a rowboat to the light of a lighthouse is 35 degrees. Well, let's look at a lighthouse for a second. This is a picture of a lighthouse. Now, notice that it stands straight up and down. So, if I go back to my drawing, the lighthouse would have to be right here. And of course, I'm not the best drawer, so I just put light in a little house. And it says that it's 96 feet tall. And it says, how far is the lighthouse from the rowboat? Actually, let's start at the beginning. Suppose the angle of elevation from a rowboat to the light of a lighthouse is 35 degrees. Well, that always goes in the same spot. Then I have this 96 feet over here, and then it says, okay, well, how far is the lighthouse from the rowboat? Well, my rowboat would be out in the water. I'm going to make it a sailboat, of course, and I'm looking for this. So this is how I set up this picture. Let's move on to the next one. So, number 2, I'm going to draw my picture. A 20-foot ladder is leaning against a wall. Well, walls go up and down, and ladders go diagonally when it leans. So this is a 20-foot ladder. It is 3 feet from the wall. And what angle does it make with the ground? So that's how I would set that picture up. Next one. Firefighters have a 17-foot extension ladder. So here we go. I'm going to need to make my triangle picture. It's always the same picture. Ladders go diagonally. We talked about that. And it has to reach 15 feet above the ground. So how far away should it be? And now I can solve that problem. So skill number 1 literally is drawing a triangle. I always draw the same picture of a triangle and figuring out where things go. So let's go ahead and look at the back, or skill number 2. I'm going to go ahead and fill in my steps because I think that that's important. Step 1, I'm always going to draw a triangle. Now, that really is just a picture to go along with what it's telling me. I'm going to then take that triangle and label it with the given information. Once I label it with the given information, I need to figure out which acute angle I'm going to be using or talking about, And then of course I'm going to label my opposite, my hypotenuse, and my adjacent sides. I'm going to cross out the one with no information. I have to figure out whether I'm talking about so, ka, or toa. And then I am going to use SOHCAHTOA and the calculator to find the missing information. These are the same steps that we've been using all along, so nothing new. The only new aspect to this lesson is to draw that picture, and it's going to be given in a word problem. So let's look at number 4. This problem should seem familiar because we set it up on the previous page. Now, I've already set it up. I know that I'm good, so let's go ahead and solve it. I'm looking for this side. So I'm going to pick my acute angle, then I'm going to label my opposite, my hypotenuse, and my adjacent side. If I look at SOHCAHTOA, I'm going to cross out or get rid of the letter H because I don't have an hypotenuse here. So I'm going to use tangent or TOA. So tangent of what? What angle did I pick? 35 degrees. And what is that equal to? Opposite over adjacent. Opposite is 96. And adjacent, I don't know what it is. So I'm asking myself now, where is x? X is in the denominator. It's down, so what do? I divide. So x equals 96 divided by tangent of 35 degrees. I'm going to put that in my calculator. Now before I do anything in my calculator, I have to make sure that I am in degree mode. And of course here we go. Quit app. Okay, mode. Oh, if I look at this real quick, this is telling me I'm not in degree mode. That's one of the biggest mistakes that is made. So we got to make sure that I get there. I go down and over, so I'm highlighting it and I hit enter. Now I'm in degree mode. I'm going to type in exactly what you see over here, which is 96 divided by tangent, of course I messed that up, tangent of 35. And what do I get? 137.1 feet. So let's go ahead and look at the next problem. So, a 20-foot ladder is leaning against a wall. The base of the ladder is 3 feet from the wall. What angle does the ladder make with the ground? What we don't need is this triangle, so I'm going to go ahead and get rid of it so that I can concentrate on what I have. I'm picking the angle that I'm looking for. If I have to pick an angle in word problems, I almost always pick it in the same spot. So I'm going to label my opposite, my hypotenuse, and my adjacent. I don't need my opposite, so let's look. SOHCAHTOA. I got rid of my opposite, so I'm going to be using ka, or cosine. Cosine of what? Of x equals 3 over 20. So now I look at this and I say, where's my x? Where's my x? It's not over here. This is a trick question. So what that tells me is I need to hit the second key. So when I do that, I get x equals cosine -1 pops up, and I say 3 divided by 20. And now I'm going to put that in my calculator. I'm going to say second cosine of 3 divided by 20, and I get 81.4. Now, I did hit the second key, and you can see that I'm talking about degrees, so that is the angle right here that the ladder makes with the ground. So let's look at our last problem. Now, here's the trick. I need to know which angle I'm picking, or which side. Let's pretend I pick this one because I've told you you're always going to pick down here. And I say, okay, I'm picking right here. Well, this is my opposite, this is my hypotenuse, and this is my adjacent. Well, I can't cross out any of those. And I'm looking for a side. I'm going to have to use my Pythagorean theorem. It's hard for me to pick an angle, and there's no x there or an angle, so that's kind of my big clue. The only angle I know anything about or I'm looking for is my 90-degree angle. My hypotenuse is my c. 17 squared equals 15 squared plus x squared. So I plug this into my calculator also. I'm going to take that 17 squared and subtract 15 squared. And I can do that in my calculator right now. Clear this out. 17 squared minus 15 squared is 64. I take the square root of both sides and x equals 8. So it's 8 feet from the building. If you remember anything about your special right triangles, your Pythagorean triples that we talked about, this is an 8, 15, 17 triangle, and I could have saved myself a little bit of work had I realized that. So go make some triangles and then solve them.